absolute convergence. A series is called absolutely convergent if the series of the absolute value of the terms is convergent. Take a look at the following example. Here you have the series of -1 to power n-1 divided by n squared. N starts from 1, goes to infinity. So if you take the absolute value of the terms of this new series that you're creating here, and starts from 1 to infinity, you're basically creating a p-series, 1 divided by n squared, and start from 1 to infinity. Remind yourself of p-series. A series of the form of 1 divided by n to power p and starts from 1 to infinity is called a p-series. If p is more than 1, then you have convergent series, and if p is less than equals to 1, you get divergent series. So as we can see, p in this case is equal to 2. Since p is 2 more than 1, we have a convergent series. So we say that, so our series is absolutely convergent. What's the connection between an absolutely convergent series and the convergence of series? Please pay attention here. We have an important note. If a series is absolutely convergent, then you can say that, hey, the series is convergent as well. If a series is absolutely convergent, then the series is convergent as well. So let us go back to our example here. We know that this series is absolutely convergent. We can use this important note and write down, since the series is absolutely convergent, we can say that it is convergent as well. So it gives us an amazing criteria to check the convergence and divergence of a series. Let us take a look at another example. In this example, I give you a series of cosine n divided by n squared, n starts from 1, goes to infinity. I want you to analyze the convergence divergence of this series. What you can do, you can say that, let us check the summation of absolute value of cosine n divided by n squared, check to see if it is absolutely convergence or not. But remember that cosine of n is always bounded between -1 and 1. And at the same time, when you're taking the absolute value of cosine of n, it is less than equals to 1. Now, you can compare this series with a series that you already know how to deal with. If you divide everything by n squared, the series on the right-hand side is a p-series. Taking 1 over n squared, the summation of 1 divided by n squared is a p-series. P is equal to 2. It is more than 1. So the series on the right-hand side is a convergent series. Since this series is convergent, you can say that, hey, the series on the left-hand side, the smaller series, is also convergent. So this series of absolute value of cosine of n divided by n squared and starts from 1 to infinity is also convergent. So what did we do? We had this series summation of cosine n divided by n squared and start from 1 to infinity. We check that the absolute value of the terms, if you take the series, if you take the sum of the absolute value, it is going to be convergent. So the series is absolutely convergent. It means that the original series cosine of n divided by n squared and start from 1 to infinity is also convergent. As easy as that. Let's recap this. A series is called absolutely convergent if the series of the absolute value of the terms is convergent. For example, we have the series of -1 to power n minus 1 divided by n squared. This series is absolutely convergent. Why is that? Because we can compare this series when we are taking the absolute value by a p-series. This is basically a p-series when p is equal to 2, and this is a convergent p-series. So the absolute value of terms give us a convergent series. When you have a convergent series in the form of absolute value of the terms, you're going to say that it is absolutely convergent. But the thing is that if you have a series that is absolutely convergent, for sure it is convergent. So you can say that, hey, the original series is convergent series. This is also an alternating series as well. So when you're dealing with a series, you can apply different techniques, different methods. Another example was the series of cosine of n divided by n squared. Is it absolutely convergent? How do we analyze the convergence and divergence? If it is absolutely convergent, you can say that it is convergent as well. When you take the absolute value of cosine of n divided by n squared, since cosine of n is bounded between -1 and 1, absolute value of cosine of n is less than equals to 1. Divide everything by n squared. On the right-hand side, you have a general term for a p-series. For the p-series, since p is equal to 2 and more than 1, it is a convergent series. Since the larger series is convergent, the smaller series is also convergent. Since the series is absolutely convergent, it means that the original series is convergent as well.